All right, so for the past few years, AI has basically been a content machine, right? It writes things, it makes images. But in 2026, all of that changes. We are seeing a really fundamental shift from an AI that writes to an AI that does. And let me tell you, the real revolution, it's not happening in a chat window. It's happening in the terminal.
So to really get our heads around this, we're going to break it down into 5 key parts. We'll kick things off with what's called the Agentic leap, and then we'll see how AI is literally breaking out of the browser. After that, we'll dig into the hard data that proves this isn't just hype. Then we'll look at the immediate impact on DevOps. And finally, we'll map out the completely new engineering stack that this world is going to demand.
Okay, so let's start with the big one, the agentic leap. And I want to be super clear here. This is not just another small improvement on the AI we already know. We're talking about a fundamental move from AI as a content creator to AI as an active, doing participant in our workflows. It's a totally different class of tool.
Yeah, we're officially in the era of agentic AI, and this definition right here is key. It's all about an AI's ability to act independently. It's not just passively answering your questions anymore. No, it's actively pursuing a goal you give it by using reasoning, planning, and, this is the most important part, actually executing with tools. You know what's so great about this slide is how stark the comparison is. We are moving from reactive systems that just sit there waiting for a prompt to proactive systems that actually go after a goal. It's not about generating content anymore. It's about executing real tasks. The brain in a jar is being swapped out for a digital worker that can actually get things done. Now for the core technical breakthrough. And for anyone who lives and breathes DevOps, this is where things get really exciting. The AI is finally breaking out of the browser. It's leaving the web UI behind. This quote just nails the whole trend. The center of gravity in AI isn't about generating static stuff anymore. It's all moving towards enabling autonomous workflows. And to pull that off, the AI has to get out of the browser sandbox. So what do we mean by native computer use? It means direct OS-level control. We are talking about an agent that has access to a terminal, to a shell. It can ls, it can grep, it can cd through file systems. It has a sandbox editor to actually change code. It can install dependencies, spin up servers, and debug, all by itself, inside a secure, isolated OS. This is the leap.
So look, these are some pretty wild claims, but as engineers, we all want to see the proof, right? We need data. How in the world do you measure an AI's skill at actually operating a computer?
And this is exactly the question we should all be asking. Is this stuff real? If you're telling me an AI can work like a developer, how do you prove it? How do you benchmark that capability in a way that's objective and repeatable?
Well, the answer is Terminal Bench 2.0. This was developed by Stanford and the Lade Institute, and it's not some theoretical exercise. It's a benchmark that throws real-world messy engineering tasks at an AI agent and scores its ability to solve them entirely within a command-line environment. No hand-holding. And this is the number that changes everything. 75.1%. That's what GPT 5.4 scored on Terminal Bench 2.0. That's not just an improvement, that is a massive jump that tells us these systems have officially crossed a critical threshold for autonomous capability. Now, let's put that number into perspective, because context is everything. On Terminal Bench, you can see GPT 5.4 is way ahead of Claude Opus 4.6. On SWE Bench Pro, which is all about fixing real-world software engineering bugs from GitHub, it's also got a big lead. And look at OS World, which tests general computer usage. It's the first model to actually beat the human baseline. The data couldn't be clearer. When it comes to native, terminal-based execution, GPT 5.4 is in a class of its own. Okay, so a high benchmark score is awesome. But what does it actually mean for our day-to-day jobs? How does this amazing new skill translate into real-world impact for software engineering and DevOps teams? This slide does a great job of clarifying the different philosophies here. OpenAI has clearly built GPT 5.4 to be the execution specialist. It's optimized for speed, for autonomous terminal use. It's that digital worker we talked about. Anthropic, on the other hand, seems to have designed Claude Opus 4.6 as the reasoning architect. It's better at really deep, complex refactoring that might take hours. They're basically different tools for different kinds of jobs. So it's really crucial to understand how this works under the hood. The agent actually follows a workflow that should look pretty familiar to any engineer. It starts as a planner, reading a GitHub issue. Then it becomes a navigator, exploring the codebase.
Then it puts on its editor hat to modify the code, and its verifier hat to write and run new tests. And finally, and this is so important, it becomes a reflector. It reads the error logs, figures out what might have gone wrong, and then it just repeats the whole loop. It's the classic write, run, debug cycle, but now it's completely autonomous.
And this capability just unlocks a whole new level of automation for DevOps. We're talking about agents that can navigate super complex code bases on their own, manage CI/CD pipelines, write cloud config scripts, and then submit a complete pull request, all without a human ever touching the keyboard. And these aren't simple little tasks. These are high-value, complex operations that used to take up a ton of our time.
Which brings us to our final section, and honestly, this might be the most important part of this whole explainer. In a world where we have these autonomous agents, the model itself is just one piece of the puzzle. The stack you build around it becomes just as critical, if not more so.
I love this quote because it's just so true. It completely reframes how we need to think about this. The frontier model is this incredibly powerful new component, but it is not the whole system. The environment you build for it, the tools you give it access to, and the instructions you provide, that is what's going to determine whether you succeed or fail.
And this gets us to this new discipline of context engineering. This is all about strategically managing all of the state and information that's available to the model. It's about making sure every single token you feed it is maximized for utility so you can get consistent, reliable results every time. And this, right here, is quickly becoming a mission-critical skill for senior engineers.
And this chart just brilliantly shows you why it's so vital. Just look at the difference here. The solid bars are with no special prompt, and the striped bars are with a well-designed system prompt. Across the board, instruction following, safety, verification, a well-engineered prompt dramatically improves the agent's behavior. This isn't just a nice-to-have. It's an absolute requirement for running these things reliably in production.
And all of this leaves us with the big lingering question. If AI agents are now handling more and more of the direct execution, the coding, the debugging, the deploying, what happens to the role of this senior engineer? Well, it evolves. The new job is less about writing every single line of code and much more about the architect of the system that does the writing. It's about designing the prompts, engineering the context, and building the guardrails for these incredibly powerful new digital workers. It's a huge shift from pure execution to orchestration. And that is the next frontier.